folks, welcome back. This is Joel, and in the next few set of videos, we'll be talking about Cisco Data Center, and very specifically, we'll be talking about the SDN side of it, which is obviously ACI, Cisco ACI, right? Now, Cisco ACI is a very tricky topic, and also not being able to create a home lab makes it even more trickier, right? Because the only partial solution to learn ACI is using the ACI simulator, but that also doesn't give a very full-fledged way, because you really can't simulate the data flows. So let's try to make the best of what we have, right? So the set of videos would be mainly trying to tackle some of the ACI tricky topics, right? And we will also be doing some labs using the D Cloud and so on, right? So let's get to it. Let's start with let's go back to my whiteboard here a bit. Let's talk a little bit about why do we need ACI, right, to begin with, right? So let me just grab that. Yeah, there you go. Cool, that looks good. Is my pen working? Yes, that is. All right, so when we talk about ACI, right, let's dial it back, right? I've been hearing ACI for easily 6-7 years now, I guess. Since the day I started working in networking, I've been hearing about ACI. So it's kind of like a pretty stable solution now, right? So when you look at ACI, right, when you try to probably think about ACI, I think you need to dial back to the traditional data center architecture, right? And mainly from the operations side of it, right? So when you look at it, I'm a network engineer. I'm a network engineer at heart, right? So I'm this guy. So I basically sit here. I'm the network guy, right? So as a network engineer who works in a data center, right, your day-to-day job is to, again, I'm talking from a traditional network engineer point of view, right? Your job is to basically use this amazing tool, which is CLI, and configure the network, right? And data centers are generally kind of like very evolving and very dynamic environments, right? Because why? Because of the guys on the left, right? Who are these guys? These are our developers, right? The software developers who basically, what do? They build apps, right? So on a day-to-day basis, they build apps, right? So if you are talking about an organization, say, I don't know, maybe anything like a financial organization or maybe a manufacturing, whatever, right? So different sectors have a need for data center, and developers, right, they build apps day in and day out to run the business, right? Now the interesting thing here is the apps which these people build, right? It's not very it's not like all the apps have the same characteristics, right? Different apps have different characteristics, right? They have characteristics with respect to bandwidth, with respect to QoS, with respect to security, right? So different apps have different characteristics, right? Now that makes it even more tricky, because, right, if I have 10 different developers building 10 different apps, and if they are providing me, right, in a Word document or a PDF, right, I have to translate all of that into CLI and push it down the network. Now that's really not scalable, right? Because if you think of a 3-tier network, or or even 2-tier whatnot, right? If you have a traditional network here, right, it's as and when you're doing these changes, right, you really need to touch different points in your network, right? It's not like you are going to do these changes only at one single switch, right? You would probably have to touch you will have a lot of touch points in your whole network to accommodate these various application profiles, right? So what I'm getting to at is it's really not scalable to kind of like do this manually, right? So with ACI, so the ACI is basically, it brings in what we call as the policy driven infrastructure, right? So the same diagram, if I have to put here with a slight change, right, you have your network, right? You still have me, obviously. So ACI is not going to remove network engineers. You still are going to be there, and then the developer is still there, right, who's building the applications just like earlier. The only difference is we could probably add another section here called as policy, right? So what is happening now is that, right, all these amazing application profiles which the application really need, right, the application characteristics, right, they can all be translated into policies, right? In fact, reusable policies. And now I no longer have to use CLI to deploy these policies on the network. Rather, I can use APIs, right? So that's one of the most important. So with the ACI, what we call it as a policy driven, right? So this is the policy driven infra, right? So we are no longer banking on using CLI to push those hundreds of changes into the network. Rather, all the application characteristics can be now bundled into various policies, and these policies we'll look into later. They are going to be what we call as a reusable policies, right? And they can be pushed down to the network using APIs, right? Now this is scalable, isn't it, right? Because I really when you're talking about APIs were developed for machines to understand, right? So I can really have any number of policies created here, and I can deploy them at a click of a button, right? So, and this all ties back to what Cisco has been marketing for a long time now, which is intent-based networks, right? IBN. So so I think that kind of gives an idea about why, right? The why part. Okay, cool. So all right, so that was a very broad definition of why. But if we have to dig deeper, right, and clearly list out all the, probably not all, but at least the most important ones. Let me just get rid of this a bit. Just use this. All right. So if you have to list out stuff, right, at least the things on the top of my mind would be, the first one is topology, right? So the topology, when you talk about topology, you again have to what is the traditional 3-tier architecture which was used in, or which is probably still used in some of the data centers, right? You have your aggregation layer here, you've got your access, right, and then you've got your core, right? All of these guys connecting up like this, right? And then the guys connecting up as well like this. All right, so this is in your access and this is your core, right? So this is your traditional network. Now when you're talking about traditional network, what was the case? This was your L2, right? And this was your L3, right? And with this came the problem of spanning tree protocol, right? You had your STPs, and because of STPs, some of the links over here were getting blocked, right? The utilization was going down. There have been a lot of technologies over the years like VPC and Fabric Path and VXLAN and all of that, which have come to kind of like fix this, right? But in a traditional network, right, this is what you basically come across, right? So with the ACI, what happens is they use this very cool architecture, let's say that, right, which is basically your spine and leaf architecture, right? So in a spine and leaf, you have your spines over here, and then you've got your leaves, right? Okay, that color did not get changed. Let me change that. There we go. So you've got your leaves here, right? And very important thing, the leaves don't connect to each other, the spines don't connect to each other, right? The leaves connect to spines this way, right? Every leaf connects up like this, and these both. And you need to always remember, spines don't connect to each other, leaves don't connect to each other, right? Now the cool thing about this is, first thing is, you really don't have your L2 stuff, right? It's a very simple topology, right? Why I'm saying it's simple? Because if you want to add bandwidth, right, you want to add the bandwidth to your network, you want to add more throughput, more power to your network, you simply go and add a new spine, right? Or you want to add more ports. Let's say you are going to have your company is procuring more servers, so you want more port density, right? In which case you go and add more leaves over here, right? And you see the topology is very simple, right? It's not complicated at all. It's very simple. And the other interesting thing is the number of hops, right? So the number of hops. Now look at this particular topology over here, right? If I have, this is all going to be L2 here, right? This is L3, right? And imagine I have one more pod, right? So when I say one more pod, something very similar to what we have here, right? Let's say we have one more pod over here, right? Probably, connecting up to the cores here like this, right? So if you have one more pod, what happens is, if you want to talk between any two guys here, let's say, this guy wants to talk to maybe this one, right? The traffic has to really traverse all the way up here, right? Get routed on the core and then come down like this, right? Look at the number of hops it has to go through, right? And when the number of hops increases, right? When the number of hops increases, what happens? The configurations also increase, right? Because you now have to take care of the QoS along the path. You need to take care of all the, L2, L3, whatever you have to do. You have to take care of every single thing, right? For these two hosts to talk to each other, right? But in case of a leaf spine architecture, right, your job is really reduced because you just have two hops wherever you want to go, right? So you have, say, this is one and the other client is sitting here, right? Whatever it is, you still have, you can just go one hop up to the spine, come down, and boom, there you go. You can talk. So you can talk between any two clients, right? Anywhere in your whole ACI fabric with just two hops, right? So that's why we say the topology is pretty simple, and scaling this is also very simple, because you really, depending on your agenda, you want to increase your bandwidth, right? Then you go and add more spines, port density can be increased, and so on. So these are some of the cool things. Let me just reduce the size of this a bit. Can I? Yeah. Okay. So that's mainly with respect to hops, right? The second thing, what else? Security. Security is a very important piece as well, right? In your data center, the security piece. Let's talk a little bit about security. Now, when we talk about security, what happens is that, in a data center, right, L2 domains are very prevalent, right? Because, again, one of the easiest example probably would have heard a million times is vMotion, right? So with vMotion, especially when you want to do vMotion, we probably have a couple of videos on my channel as well about VMware and so on. You can go and check out. But mainly when you do vMotion, you really need like a L2 domain, L2 broadcast domain, right? Now, think of it, right? If you want to kind of like isolate traffic at L3, you can use VRFs. But in a single L2 domain, right? Let's say this is like, I don't know, VLAN 20, right? So if you have multiple hosts sitting here, right, in this particular domain, if you want to restrict traffic here, it becomes a little tricky. You probably need to use some kind of a firewall, right? You will have to use some firewall which works in like a L2 mode, like a bridge mode, like ASA in a bridge mode, something transparent mode, and so on, right? So to restrict traffic, or maybe you'll have to think about things like private VLANs, it's a very tricky topic again, and very obviously gonna take a lot of amount of your time to implement this, right? But with ACI, what happens is you have this amazing security model, which is like the whitelist model, right? So in whitelist model 2, what you can do is that, you basically create what we call as those EPGs, right? Endpoint groups. Now, totally fine if you don't know what EPG is, because it's a ACI construct, and we have not really talked about any of the constructs yet. But just to give you an idea, right, you can create what we call as EPGs, right? Endpoint groups, where you're basically grouping all the endpoints, right, which belong to one particular functional unit, right? And you basically group them, and you can define the contract over here, right? So you can define a contract. You can think of it contract like an ACL, right? You can define an access list, right? So L2 domain, either you would not really need a firewall. You can just create your EPGs, and you can define contracts, and you can define the access, right, using this whitelist model. Why do you call it as whitelist? Because by default, no two different EPGs will not be able to talk to each other, right? Unless you really explicitly whitelist those both EPGs to talk to each other, right? So that's why I call it. So security, and again, all of this, going back to my previous diagram, all of this can be driven by the policy, right? You really don't have to configure anything manually. You just need to use the GUI, build some policies, in fact, these policies are going to be reusable modules, right? So you create a policy once, you can reuse it in different areas and different contexts, right? But all of this is automated. So that's second thing. Third reason. What is the third one, right? We probably already talked about this earlier, right? The management side of it, right? The management part of it. We talked about this earlier, right? I mean, to configure anything in the network, right? We don't really have to use CLI anymore, right? We can do all of that using the API, right? And the Epic controller will do it for you, right? So we talked about this. I'm not gonna again drill much on this, right? And probably the other one is kind of closely related to management, which is programmability. I think my spelling is wrong, but that's fine, right? So with what I mean by that is, right, the whole ACI, we have not talked about the components of ACI, but there is a very important component of ACI, which is the Epic controller, right, which sits here, right? And the Epic controller, right, on the northbound, right, you can obviously in the southbound, it is obviously controlling your devices, the network, devices over here. But on the northbound, right, it exposes APIs for you, right? And with one of the main important aspect of SDN is you really need an open controller, right? And that's the case with all the other Cisco controllers as well. We talk about vManage, you talk about DNAC, right, in SD Access, right? They all have APIs, and they are trying to keep them as open as possible so that people can programmatically access this controller, right? The whole idea of having a controller is centralized management, but then it should also be open, right? So that network engineers can, right, use their scripts, use their Python scripts, use their various automation orchestration tools to go into the controller and provision the devices as per their needs, right? So that is another interesting piece of it, right? So I think we've kind of covered a bunch of things, right? And again, I'm not there is obviously, this is not the these are obviously not the only 4 options, right? Because I can again think of a lot of other things, like for example, with the latest advent of ACI, with the latest development in ACI, one of my favorite feature is how ACI can be dynamically integrated with things like VMware, right? Because I mean, I think Cisco understands that in a data center, you're probably going to have a lot of other products other than Cisco products, right? You're going to have VMware, you're going to have OpenStack, right? You're going to have Kubernetes and so on, right? And it really is important, if you're building a controller such as Epic, it's really important to have one single pane of glass to control your whole data center and not jump on 3-4 other controllers, right? Because from a VMware perspective, what is the controller? We use vCenter, right? I'm not very familiar with the other products because I don't use them on a day-to-day basis. But if I have to talk maybe from a VMware perspective, vCenter is something which is very powerful, right? Because I can control my whole virtual workloads using vCenter, right? I can create my virtual switches, I can create those port groups, I can deploy new VMs, I can put some policies for my VMs. Everything can be done sitting on this vCenter, right? But again, if I end up allowing, or if I end up having 10 different dashboards for 10 different products which are running in my data center, it's really going to create a lot of operational hazards, right? So one of the very cool thing about ACI is the VMM integration, which basically makes it super easy for me to sit on this Epic here and also manage my other integrations, right? So I can go and create, like as simple as an example, I can create a port group, right, sitting on API on the Epic. I can create a virtual switch, right? I can create a virtual standard switch, or I can create a virtual distribution switch sitting on this Epic, and all the configurations can be pushed down. Now that is again the cool thing, right? Because everything here is driven with APIs, right? They have integrated it in such a way that I can sit on Epic and do everything, right? So I'm not going to spend more time on this. I think the message is clear, right? Why we need Epic, why do we need ACI in our data center? And especially in the current scenario where we have a lot of changing dynamic workloads, this really makes sense, right? All these 4 important points, right? Cool. So let me just grab. Okay. So we've talked about a little bit about why we need ACI and so on, right? I think it's time to talk a little bit on the ACI, the structure, right, and then probably the components of ACI, what really makes up the ACI, right? So a simple diagram you would have seen me already draw is the leaf spine architecture, right? So you've got your spines, right? Generally this is your 9500 Nexus switches, right? Big ass switches. These are like, you know, chassis switches, 9504, 08, 16, right? And then you've got your amazing leaf switches, right? Which are generally your 9300s, right? Like this. And like I said, again, probably you would see me explain this again and again, but always remember your leaves don't connect to each other, spines don't connect to each other, right? And this is how the connections are always there, right? And the other important piece is your epic, right? So these are nothing but, think of it as a UCS boxes, right? And generally you have how many? You're gonna have like 3 of these guys, right? So 3 of the epic controllers, right? Very similar to our, if you want to compare this with your SD access solution, then your DNAC, just like your DNAC, you're gonna have your epic, right? And they again connect up to the leaves, right? Probably it's not that they have to connect up, all of them have to connect up to the same leaves. So you know, they can, but you know, probably I can connect it this way as well, right? So you have the epics, and then obviously you're gonna have some kind of, because generally what we see in ACI is that if it's, unless it's a, generally it's a brownfield kind of a deployment, right, where you already have a data center and you're kind of trying to either slowly migrate to ACI, right? So you would need what we call as some kind of, connectivity to the outside, network. So everything in ACI connects up to the leaves, nothing connects up to the, spine, right? So you have everything. You will probably have your, your traditional servers and all of that kind up here. You would probably have your L2 or the L3 existing networks connecting up here. So everything is getting connected at your what? At your leaves. Nothing connects up down the spines. Sweet. All right. So that being said, so what are the 3 important components I would really call out? One is your spine over here, one is your leaf, and this one is your epic. So these are like your 3 components, 3 important components, right, of ACI, of the whole architecture. Okay, so that being said, we will probably talk about the leaf and spine topology. I think we have already talked a little bit about the leaf and spine topology earlier, right? We talked about how simple it is, how easy it is to scale. There is no STP, right? It's all L3, right? So this is the whole fabric network here. The fabric is basically this part, right? We just draw it. So this is literally the fabric, and this is nothing but your L3, literally L3. And because it is L3, you're probably going to be running some, this generally ACI runs what we call as the ISIS protocol, right? ISIS, you generally see it in service provider environment. Why do you run it here? It's mainly because of scalability, right? We are talking about building a scalable data center, so you really need to use a L3 protocol which is scalable, right? So yeah, that being said, we'll talk more about, the packet forwarding, the control planes, and the data planes probably in the subsequent videos. I just wanted to introduce you to ACI here. Probably we could also talk a little bit about your hardware, right? So let's just get rid of this, right? So when I talk about hardware, right, because that's something, very important. Again, if you are planning to build your own, I don't know, maybe like a ACI lab or something, so to talk about the hardware part, right? Yeah. So when you talk about hardware, what do we have? Like I said, we've got the ACI basically runs on what we call as Nexus, the Nexus product line, and in the Nexus product line, mainly the 9K product line, right? So so let me try to introduce a little bit, right? So when you talk about 9K, there are mainly 2 products here. One is the 9500 and this is the 9300, right? So the 9500, they come in like, I believe they come in like 3 different flavors, right? They are basically the chassis ones. This is your chassis, the big chassis, right? If you have seen a Cisco chassis before, right? It's a big solid chassis, right? They when I say chassis, it means that it's modular, right? I can plug in a bunch of things, and the top of my mind I can think is I'm gonna have my line card, I'm gonna have my supervisor, right? What else? I'm gonna have my fabric modules here, right? There are other pieces which really makes the puzzle come together, right? So fabric modules are basically this, again, think of it as like a backplane kind of a thing, right? So if for the various line cards to talk to each other, it has to happen via the fabric modules, right? And probably I'll show you a diagram and try to show you how all of that comes together, right? So you've got the fabric modules, and again, probably another component, we call it as the system controller, right? So system controller, again, if you have not heard of it, if you are coming from, again, an enterprise network, if you have not heard of it much, what they have done is, think of it this way, right? They have kind of tried to reduce the load on the supervisors, right? And they have offloaded some of the functionalities onto those system controllers, like managing power, temperature, and so on, right? So those kind of activities are given to the system controller, right? So these are some of the components which basically makes up your this huge 9500 chassis, which come in, I think, 3 flavors: 4 slot, 8 slot, and 16 slot, right? So now let me just show you, if I think I have loaded up a diagram here. So you can anytime go down to the Cisco space, look at the latest 99K series products, right? You can see here, this is your modular switches, this is your fixed. So 9300, they are your fixed switches, right? They are not modular, right? They are fixed, right? Top of rack kind of switches. And then you also have the other non-ACI. So always remember, when you're probably going and procuring Nexus switches, make sure that because you need to get only those devices which are ACI compatible, right? So there are either they can run, there are some line cards and products which can run NXOS, the traditional NXOS, or the ACI, and then there are some modules which can run only ACI or NXOS. So you need to be careful and get the stuff which you really want. And I would personally recommend getting those modules or those devices which support both, because if you are really not happy with ACI and you want to run a traditional network, you could probably run that as well using the traditional Nexus, right? So that being said, you can compare the modules and stuff. I think I have loaded up one of the 3D model of I don't know which one is this. This is let me see here. Yeah, so this is a 9500. I think it's an 8 slot chassis, right? So if you look at this is how it looks. So let's look at the 3D model. There you go, right? So you've got your 8 slots, the 8 line cards here, right? That's what you see here, the various 8 line cards. Obviously there are different versions of the line cards, right? Of late, if you see on the, maybe I'll show you that again later, what you see is all throughout the Cisco Nexus website, you see the word cloud scale, right? So the earlier line cards, they used to be called as classical line cards, right? And now Cisco has moved towards the second generation high throughput cloud scale architecture, or cloud scale, where they're using different kind of ASICs and making it more modern data center, supporting 100 gigs and so on, right? So that's your line cards here on the top, and this should be your supervisors, right? You've got your supervisors here. It's a dual soup kind of a situation here, right? So the supervisors basically go up here, and then what do we have? Let's see. So at the bottom you will have your power supply, right? So these are power supply units. That's tilted back, and here you basically see your fan trays and the system controller, right? I talked about system controller. They are the ones which sit here in the bottom, and there should be the fabric modules as well, which sit here behind the fans, right? Let me see if I can show that. Yeah, there you go. This is a fabric module, and yeah, there you go, right? So if you see here, they actually sit behind the behind your this fan modules, right? So if you remove the fan trays, you basically see this, the fabric modules, right? Now that's literally your traditional, that's literally your Nexus, 9500, and this is a 8 slot. Similarly, you can go either with a 4 slot or 16 slot chassis as well, right? And they are used for what? They are used mainly for your spines, right? So that's mainly about your 9500. Okay. Now 9300 is another set of devices. Like I said, these are obviously not, they are not chassis, they are fixed, right? And I mean, both of these, there are modules, which can be used as spines or leaves. So, 9500 as well, you have, I mean, I would rarely, I think no one uses it that way, right? Because 9500s are these heavy boxes, you would really not use it for, leaves. But I believe there are some modules here which can be used for leaves as well. But traditionally, you use 9500 for spine and 9300 for leaves. But 9300s can also be used for spines as well. There are few devices here which can be used for spines. So if I personally, if you ask me, if I'm building a home lab, right, and if I want to go on eBay and get some ACI switches, then I would probably stick to only 9300, right? Get probably one or couple, spines and maybe another couple of leaves, because they are going to be cheaper and it will be easier for you to build your lab, right? Now coming to 9300, like I said, a little bit of history here, right? With respect to ASICs, probably if I can explain, right? So with the ASIC which was used in this 9300, Cisco has always used its own ASICs, right? They create their own ASICs, right? So why do they do that? Because if I'm a vendor and if I'm creating my own ASICs, then I have more flexibility about what features can be deployed on it, right? Instead of relying on someone else to build my ASIC, right? But then Cisco also has used what we call as merchant ASICs, right? So that is merchant silicon, right? And Cisco has used it in some of the products like Nexus 3K, I believe, right? So this was where Cisco used the Broadcom, silicon. With the Nexus 9K, Cisco went with what they call as the merchant plus, right? Kind of strategy where, some of the silicon was done by Cisco and some of them was done by Broadcom, right? So if you look at the initial, what they call as the generation 1, right? So there was generation 1 series of line cards where, it had 3 important ASICs. One was called as ASE, other one was called as ALE, and the other one was called NFE, right? Now, these both, ASE and ALE, this is basically nothing but spine engine and the leaf engine, right? So this was obviously made by whom? Cisco. And this one, the last one at the bottom, right? So this was nothing but Broadcom. This was made by Broadcom, right? So this is your Gen 1 kind of ASIC, right? This is the ASIC which basically went into the line cards, right? ASIC is very important, right? Because that's where the whole packet switching and all of that happens. So, but in Gen 1, what they did was they kind of built the line card with 3 ASICs, right? And obviously ASE went into spines, ALE went into leaves, and NFE was the merchant silicon, right? So some of the common features were offloaded onto this ASIC, right? That was Gen 1. And with the Gen 2, so this is generation 1. With generation 2, what they did was, let's say, they came up with what they call as, forgot the name, it was LSE, right? They came up with a ASIC called as LSE, which was nothing but a combination of these both, right? Which was over here, ASE and LSE, right? So they combined both of that into one single ASIC called as LSE. And obviously the NFE was there which is the Broadcom, the merchant silicon, right? That was still there, but they just combined these both into one single engine called as the LSE, right? Leaf spine engine. Earlier it was spine engine and leaf engine, but here they combined both of them into leaf spine engine, right? So those were 2 different kind of generations, right, of ASICs, right, which Cisco has used. in its line cards, right? So let me just get rid of this. Let me show you some of the line cards, right, just to give you an understanding of this. So Gen 1, Gen 2, right? If you are procuring some of these devices now, I would personally recommend you to check out the latest ones, right? Obviously, for your so that you have some ROI and you get investment benefit out of it, right? So if you look at the cloud scale 9300, if you look at the cloud scale line cards over here, you would see you can see you have EX, FX, FX2 and FX2, right? So your all of this EX, FX, FX2, all of these are Gen 2, right? They are all cloud scale line cards. I don't think you have the Gen 1. I think they have gone end of life now. I don't think you'll probably find the Gen 1 anymore, right? So EX, FX, FX2, all of these are cloud scale. But if you are procuring it now, I would obviously recommend you to go with the FX2, right? Because they are the latest ones. That being said, you can see here it clearly tells us what these particular line cards are used for. In fact, all of these are used for the leaves. But I think probably if you look at these, maybe you probably will see spine as well over there, right? See here, you can use it for spine as well, right? So that's why I was telling you 9300s can be used for both leaves and spines, whereas 9500s generally, I think 99% of the deployments where I have seen, they have used it only for the spines. Yeah, so that's mainly it, guys. So I think, all right, so I think there's one more thing before we wind this video, which is the EPIC controller in itself, right? So the EPIC controller, as you see here, I've just pulled out the documentation on that. It comes in mainly two different form factors. One is your medium, which is your M3 form factor, and the other one is your large, which is your L3, right? And you choose the one which meets your requirements, right? And I think one of the most important criteria is to check the number of edge ports you have in your network, right? If you have up to like 1200 edge ports, then you can go with M3. But if you have more than that, then probably you would want to stick to a large appliance, which is your EPIC. And these are nothing but your UCS C servers, right? Nothing other than that. And you obviously deploy this in clusters, right, for the whole HA and high availability purposes. So you have two different form factors for that as well. You have the medium cluster and then you have the large cluster as well. Cool. The other thing is, if you want to see the distinction between the M3 and L3, you can check that out. One of the important criteria or the distinction is that you get 16 GB, right, down on your M3, 16 GB multiplied by 6 because you have 6 units of RAM, right? So whereas when you look at the L3, you can see you have like quite the double, right? So that's that, right? Cool. So hope that was useful, guys. We talked about ACI, why we need it. We talked about the hardware components, right? We talked about right, what components go where, spine, leaf and stuff, EPIC, right? That was a very brief introduction, I would say. Yeah, so I think in the next set of videos, we'll be talking about some cool stuff like the hardware, the logical models, the physical models, and the packet forwarding and all of that, right? So do tune in and come back. Have a good day. Bye.